What is printing, people? Welcome back to Custom 3D. Today's video is going to be a brief history about 3D printing. "3D printing is undoubtedly one of the fastest growing industries in the world. In 2020, the industry's estimated worth was $13.63 billion, up $2 billion from the previous year. In 2018, 1.42 million individual 3D printers were sold throughout all different companies within the industry. According to Grand View Research, they estimate the industry will be worth $35.38 billion by 2027, and trust me, that is a conservative estimate. I think it might even be higher than that due to, I think COVID actually upsold 3D printers, and obviously they didn't predict COVID to happen. So I think you could see the industry being worth $10 billion more than that by that time. And in 2027, they also estimate that they have sold over 8.04 million machines that year. I think, again, it'll be higher than that. So additive manufacturing, which is another term for 3D printing, was first created in 1984 by Chuck Hull. The first type of printer he designed can be classified now as stereolithography or SLA technology. Chuck wanted a faster and more cost-efficient way to create prototypes. CNC and injection molding processes were expensive and had many limitations. These were the other two types of manufacturing technologies that exist and still exist today. CNC being used more for prototyping than injection molding, obviously, because injection molding you use for a lot of long-run manufacturing items. Basically, every plastic piece that has been manufactured in the masses has been injection molding. Around the same time of Hull's invention, Scott Crump, the co-founder of Stratasys, created FDM, Fused Deposition Modeling, otherwise known as FFF, Fused Filament Fabrication. This is the most widely used technology today, even though being the second type of 3D printing invented. So like Hull, Crump wanted a more efficient way to create prototypes, but without the detail-oriented processes and pre-processes involved with SLA technology. Now, SLA, due to the liquid resin it uses, is very difficult to use and messy, and the resins actually can put off some harmful fumes if you breathe it in too much. So you need a really good air purification system where you are, and sometimes they even recommend that you wear some sort of mask or respirator or ventilator. I don't know what it's called, but something to protect your innards, if you ingest it too much. So FDM technology provides a much simpler process than SLA technology. It can offer highly accurate models, although not as finely tuned as SLA, using a spool of plastic filament that is slowly fed into a hot extruder and then onto the build plate. The mechanics of this technology works differently compared to SLA. However, the process of building items through layering is the same. Three-stepper motors work together on the X, Y, and Z axes to move the build area and extruder so the print can be built. Not only is the process simpler, but the technology boasts a significantly larger range of materials to choose from. Acrylic-based resins with SLA offer, some rigid materials and some flexible materials, but not that much. You're talking maybe 5 to 10 different types of materials. However, with FDM, you're talking a range from rigid to high temperature flexibles. FDM offers an extensive range of material properties suited to most every application. Even more recently, you can print in different types of metals and carbon fiber additives within types of plastics like ABS, PC, and PLA. The additive manufacturing industry is getting more intricate due to the addition of new technologies. While the most popular types of 3D printing remain FDM and SLA, there are several other technologies not yet mentioned in this video. And here are some other ones. So you have SLS, selective laser sintering. Then you have DMLS, which is direct metal laser sintering, and polyjet. So SLS, basically like FDM and SLA, it was actually created in the 1980s. The creators are Dr. Carl Deckert and Dr. Joe Beeman out of Texas. SLS uses a high-powered laser that melts or fuses small particles together. These particles are finely ground powders of different plastics. DMLS is basically the same process, just uses metal instead of the plastics. And polyjet is very interesting. So Stratasys, for years, was the only company who had the rights to FDM 3D printers. Due to the expiring trademark, that's why FFF is also around, because FDM was trademarked by Stratasys, and hobbyist machines needed, to classify the printers, so they call the FFF fused filament fabrication. So, since they were no longer able to keep their name Stratasys, luckily they had something else in works. Polyjet is a Stratasys exclusive additive technology using a very similar acrylic-based resin to SLA. Polyjet technology uses print heads with extremely small nozzles, able to jet out photopolymers simultaneously cured by a UV light. The minuscule print nozzles can print with incredible detail down to 28 microns. And the technology on the new Stratasys polyjet printers, you can print over 500,000 different colors. And it's insane what you can do with this printer, although the price is very expensive. I think the least expensive one is like 95 grand, and I think the most expensive one under the Stratasys name is 350 grand, and sometimes it can get upwards of $1 million by the object machines. It's kind of insane, but usually the prints coming out of this are worth it, because you can print not only different colors, but that gives you the ability to print different textures. You can print like a rug, jean, bone textures, things like that, anything. But the only thing is about polyjet is it's not very good for a final use prototype. So if you have a print in place fixture like a hinge, it's not going to withstand the bending of the hinge, and it will break. That's one huge thing FDM has over polyjet, is due to all the different layers that polyjet has. There's a lot of different breaking points that are possible, and that's why it's not as strong. So, as you can tell, additive manufacturing is just an incredible new feat of engineering. It takes the process of building prototypes to a whole new level. No expensive molds, no strings, no limitations. Your imagination and dreams can become a reality with 3D printing. Think of additive like this: if you can dream it, we can build it. Sorry to rip off the guys on Animal Planet from Tanked, but I think it's more true for us than you, because we can actually create inserts that go into fish tanks. So yeah, thanks guys for watching today's video. I hope you learned something today, and I will catch you in the next one.